previous two videos, we have talked about the technical drawing basics and threads and screws. Today we will go on with all other topics quite quickly, starting with general tolerances, but now we can just begin with a short repetition of the most important information from the slides. So we will start with magnification scales. So reduction in size when the second number is bigger, for instance, 1 to the 2 or 1 to 5. And magnification is when the first number is bigger than the second. So 15 to 1, 20s to 1, and always we can use only numbers such as 1, 2, 5, 10, 20, 10, 15, and so on, as mentioned here. Here is just standards. Here's a title block for drawing. It should look exactly like that, but maybe so or similar. Also important parts list. So it looks like it contains columns such as position, quality, in head, naming, part of number, and maybe comment also. Here's types of lines. Isometric projection, which can be used in some tasks, but we won't discuss it that much. So that is our main arrangement according to the standard, how the part should like. So here's the front, here's the right side. Oh, here is just the right side, which is painted, which is constructed on the left, and the side on the left, which is constructed on the right side, and also bottom view. Is projection methods. And also the dimensioning rules. So we need a certain distance between arrow and the construction line. So it's up to 7-10 millimeters, and a bit of Oberstand, so over distance 1-2 millimeters. And we must write the number if the arrow is horizontal on the top and if it's vertical on the left side. So it's designated here. It's really essential. Regarding arrows, this arrow edge must be very sharp, approximately 15 degrees, but in reality, no one measure it. And that's all here. Here are some examples of dimension entries. We'll use mainly function related. This type. There is thickness. So this abbreviation used very commonly in different tasks. Okay. Here's also an example of parallel dimensioning, but we will use mainly rising dimensioning. It can be designated this type, or also we'll see then some tasks with different options, similar, quite similar to this. Here's also table dimensioning. Okay. Some radius we can use with arrow and R10, for instance, or diameter. So it depends on structure or if we have such rounded angle also. And yeah. Here's some examples of currents and counters, things we want to use it. Think. Here's some examples of chambers. Also table, maybe not every example here is valuable. Internal parts will mainly designated in such way. And yeah, here's some type of cuts. But again, we will look them about it in the next tasks. Further. And here's this chapter about ports and threads. All these designations and standards can be found in the table book, so I can specify it in this presentation because there are a lot of editions and it depends on the book edition. It's preferred to use always the new one. So here's some types of threads. Oh, just this definition means that MI M8 times 14. So M is just thickness metric, 8 is nominal diameter, and here's a thread length. If it's 0.5, it's a thread pitch, fine thread also called. If it's written like 30 LH, it is a thread length, left hand thread. Tables, they all can be found in the table book. We won't take in account yes, the bolts and nuts, screws. Mhm. Also, a way to designate hole. We will use here a distance 1 millimeter between the nominal and it's called outer distance, the outer line. And for throat hole, we'll use like this circumference 3/4. So we'll also take a look then. Connection. Also some examples and here tolerances, but now we will look at task of this chapter 2. So here are just solutions sketch how we can designate it, and this middle part of screw or hole always goes up to this connection or middle line. So it's also a rule of this method we have looked earlier. So it's recommended to make sketch before um, creating a complete sketch. Here are some examples. This solution of this task quite bad quality. Maybe I will add um, some time later better quality photos. Yes, it's not quite good here. And just a standard table, but there's nothing difficult. And now we go to tolerance chapter. So here the general tolerance are divided into tolerances classes. So F means fine, M medium, C coarse, and V very coarse. And they apply to length measurements, rounding radiuses, and angle measurements. So we will use general tolerance standards, which is called ISO 27668M. Here's also simplified table. In general, so this value depends on the class and mainly from the part dimensions in millimeters. But again, this can be found in the table book. Here's also nominal dimension and actual dimension. So we'll have one task example about it. Well, here are just some designations and explanation about it. So 15 here is a nominal dimension, minus 0.1 dimensional tolerance. And in the first case, has 7 is a tolerance fit. So this also can be found in the book. So going further, it's not quite actual. Here's some isofits of unit bores. So a bore with a tolerance zone H unit bore paired with a shaft with a tolerance zone results in AH clearance fit, JN is transition fit, and PZ is interference or press fit. Also, there is a term such as unit wave. It's a shaft with a tolerance field H small results paired with a bore with a tolerance field and with the grid letters AH is clearance fit, YN transition, and large PZ interference or press fit. So the fitting hole is always marked with a capital letter and the wave is always preceded by a lowercase. Here's some example of Spielpassung and Übergangspassung. So if the bore diameter is larger than a shaft diameter, it's a clearance, so-called Spielpassung, and oversize when the shaft diameter is larger than the bore diameter, it's Übermaß, Übergangspassung also. It's also very relevant. And just designations, play fit, bigger play or smaller play can occur. Oversize fit, maximum oversize or minimum oversize can occur. Transition fit, there may be play or oversize. So again, we should look at the table to get precise information regarding these tolerances. Here's a round fit example. Flat fit also. These graphs also can be found in a table book. Here's just a comparison. 1 micrometer indication of dimensional tolerance by isostandard tolerance abbreviations. So here's the diameter value, and then we write 7 class, also small each. Indication of dimensional tolerances. by tolerance abbreviation. Abbreviations. Okay, and here we have a solution for the task, which I will add maybe later, because I don't have an option now. Oh. And here we also have a third task solution. Here some examples. Now we will go to the next chapter of surface specifications. So here's the standard. It's quite important. Here's typical surface patterns, Penrose type of machining. Here's a German, but again, this can be found in English in a table book. This curved line means that the plane is unworked. So also we can designate with triangles, but it's quite outdated. Yes, this is quite outdated, so we'll mainly use this one. Yeah, translation, I didn't provide it here. But again, this can be found stable book. As long as the indication of such symbol is not meaningful, a roundness value in micrometers is given for each symbol. The roughness values are indicated with RA and RZ, and we mustn't mix them. So here in the theory, you can see here the graphs. So the middle roughness value, it's RA. So it's like an arithmetical middle value of all distances of surface in the middle line. So our surface has some imperfections, and RA is basically so this common one distance between the lines of so between these two middle lines and central line. So the roughness parameter is defined from roughness profile and given in micrometers. Oh, and roughness parameter RZ. The roughness parameter are determined from the roughness. Here's the same. So RZ we need to determine our surface sketch in some parts, and then it's calculated here in the formula given. But precise values can be found in the table book, both for RZ and A. That we won't use really. Here are some examples of designations in Germany and international surface specifications according to this parameter, which is solder, and here's also example. And usually it's measured in micrometers always. We don't need to use this measurement unit here. And I think that's all from this chapter. Here we have the first task solution, which I will also provide later. It's in German, so mainly the symbols are used here, and if it's must have been somehow transport. So if the surface has to be transformed, we usually write the process, for instance, milling or grinding here on the top. And if necessary, we need to write the Z or A value from table. So here's for another part. So functions table. Yeah. And next chapter is about form and position tolerances. So there are a lot of different types. We can divide them, for instance, like rounded form or linear form, rounded, uh, also grad height, parallel, or should it have the angle of 80, of 19 degrees? Just some older examples, but the most relevant the most relevant you can find in the table book again. So we will go on. Example of the it's called rectangle of 19 degrees angle. So we need to so the surface is in 90 degrees angle with surface A, so it must be with 90 degrees angle with surface A in 0.1 millimeters. And we mainly use this designation. So 1 centimeter, 2 and 1 centimeters. The height is also 1 centimeter for convenience. In the first box, we put the symbol value. The second number, and in the third surface name letter. Here's some other examples. So milling tools and turn. That's the end of the session. So about form tolerance, we have task 5 presented here. So the main accent we should make on these parts. Here's the front view and side view. So we should correctly designate. So we should decide where we should put the reference points such as A and B, and then sketch the additional cut for them. And also don't forget about the tolerances which we have talked about before. And also table bottom, we can also write here designations additionally. And then we have also some user practice exercises. So we need to construct this part, for instance, also using the same rules and methods. Here we needed to add a table with passing pass mass and tolerance. And this part can be sketched just as a hollow cylinder, so it's not obliged to be exactly like here. Here we have a sketch for a stopper part. I unfortunately don't have here exercises. So again, we need to follow the same rules which we have looked in presentation. Yeah, here's a clear sketch and additional tasks. Sunken. In the eighth lesson, we had again this screw. So here we have a sketch. So this middle part of screw always must get to the line of connection to the last plate. So it's sketched here. So threads designations and all parameters for screws can be found in table book. Here's a clear sketch, lists of parts which are designated here with letters somewhere. Suppose here's the position number, count, uh, the name of it, and normal designation. So again, this is provided mainly in the tasks text. And just last task about topic of calculating the mass of different parts. So here I have provided the text solutions. So main idea is basically calculate first the volume correctly. So of each of these parts, just decompose each part to simple structures. So as the first two, for instance, in 3 cylinders, and just calculate it. So as written here in the complex way, and we mainly use formulas that the mass is equal to volume times density. Usually the main problem is calculate the volume correctly. So here I have just a sketch that for a thread, a screw, we usually need to calculate the middle value. So if the outer part is, for instance, 6 and inner 5, we will take the middle value 5.5 as a diameter. And we need to calculate the screw head up part of this fight additionally. So we take the measurements from a table book. So usually it's a cylinder, and if it's just a hole, we take as it's given. For instance, M6, we take 6 millimeters diameter. So it's one of important nuances here. And the other that the densities are not provided here for materials. They can be found in either in a table book, or even we can use the internet during the exam. Also, for instance, to find the density for plastic PMMA or different types of steel, wedged steel. And in general, that's all. There were also some tasks